All right. So example number 3, the first equation is x minus 4y equals 12, and the second one is y equals 1/4 x plus 8. I need both of these to say y equals so I can like push them together, and so I converted the first one. First one was x minus 4y equals 12. I subtracted x from both sides, and I got negative 4y equals negative x plus 12. Then I divided by negative 4 on both sides. So negative 1x divided by negative 4 is a negative divided by negative is positive, 1/4. This one, the positive divided by negative, is a negative, and then 3. And like I said, the second equation was good to go. So I will set it up. 1/4 x minus 3. 1/4 x minus 3. And we'll put equals 1/4 x plus 8. We can already tell the slopes are the same. They both go up 1/4, up 1/4. But the y-intercepts are different. So we know these are parallel. So we know already. We know this is, if they're parallel, they're never going to have the same solution or a common solution. But let's go ahead and work on it, see what happens. So let's multiply both sides by 4 to get rid of this fraction. Positive times a positive is a positive. 4 times 1, I can make that a little bit nicer. Well, maybe not. Okay, positive times positive is positive. 4 times 1 is 4. 4 divided by 4 is 1. Positive times a negative is a negative. 4 times 3 is 12. Positive times a positive is a positive. 4 times 1 is 4. Divided by 4 is 1. And a positive times a positive is a positive, 32. Now right here, normally you would take away 1x from the right side, which means you take away 1x from the left side. But if you notice, it just goes away also. I end up with negative 12 equals 32, which is, like, this doesn't make any sense. Well, it doesn't make any sense because negative 12 never equals 32. This is a perfect example of that will never be the same, so there's no solution to the system. No solution to the system. Those two equations have no common solution. System. All right. Let's go ahead and look at another special case. So we have 2y equals x minus 3 and negative 3x plus 6y equals 9. Neither of these say y equals. So I changed this one first. Luckily for me, all I had to do was divide by 2. Nope, forget about that 1. 1/2 is 2. 3/2 is 2. Let me make sure y'all can see that. And that is my equation. Over here, this was in standard-ish form, so I added 3x to both sides, plus 3x plus 3x. 6y equals 3x plus 9. And I divided by 6. I divided by 6 here. And then I got positive over positive is positive, positive over positive is positive. I reduced these fractions, though. So divide by 3, divide by 3. And divide by 3 here also, and I divide by 3. You don't have to divide them, like, these, the 3 and the 6 have to be divided by the same number. The 9 and 6 have to be divided by the same number. It's just coincidence that they, like, these are 3 and these are 3. Okay, so let's go ahead and see what happens. We can already tell, though, like, look, 1/2 x plus 32, plus 3/2, 1/2 x plus 3/2. They're the same. Like, we can change this equation into, like, we can change both equations into the same exact form. So we know that they're always going to be the same. They're the same exact, like, lines. They have the same exact solutions. So this should be infinite solutions. Let's see what that looks like. So y equals 1/2 x plus 3/2. And that will we want to make that equal to 1/2 x. Well, the same thing. Plus 3/2. Let's see what happens when we do that. I'm just going to multiply it like this time, or show the multiplication like this. Positive times positive is a positive. 2 times 1 is 2. 2/2 is 1x. A positive times a positive is a positive. 2 times 3 is 6. 6 divided by 2 is 3. And a positive times a positive. Oh, it's the same thing, right? So, like 1/2 x plus 3/2. So I'm just going to write the same thing. All right, so let's go ahead and start like attempting to solve for x. So if we take this away and we take this away, like you'll notice that like you end up with the same thing. Like they are the same thing. So if you try to solve for x, the x's disappear. You just end up with this. And if you do it again, you just end up with 0, like minus 3, minus 3. But like they are the same. So no matter what you do to both sides, they will be the same. They will always be the same. This means that they have an infinite amount of common solutions. Infinite solutions. So we have infinite, I'm going to put infinite common solutions. And that is it. Thank you.